Oh, sorry. Where are we? Yeah. Yeah, so in Excel, we can just, okay, you first label, you have your curing time, okay, and then you have the concrete strength. You have concrete strength. I'm sure you can see my screen. Let me magnify it a bit. Okay, but very well. So we got this. Then let's use the same data. We have 714. We had 20, I think 28, and then we had 30. Okay, and the data set we had 30, we had 48, we had 60, and I think 70 something, 78 also. Okay, so this we can easily select. You only have to select your data sets like you are seeing here. Okay, then you go to insert at the top here. Okay, so you go to insert. Insert, you are going to have charts here. You click on the chart. Then you can see we have scatter here. Okay, so once you click on the scatter, right, we have the scatter chart showing. So we have the scatter plot showing here. Okay, with the is demanding for the chart title and the details of the chart because we didn't select the headers. Okay, so let's go back and redo it. We want to select together with what? The header. Okay, so let's go and then reinsert. Okay, so from here you can easily select the kind of charts you want. Okay, there are many options. Okay, I think this looks a bit nicer. So let's, when we select this, we can also bring the, we can bring the labels, the X and the Y labels to it. Okay, they all depend on the chart, but we don't want to spend so much time here. So what I'm basically saying is we can represent the same thing we are doing, okay, using computer softwares, okay, and we can even make it in 3D and all that. Okay, very good. Let's continue with our study. Then again, let me just touch on this before we go to the regression. Okay, we could also, instead of limiting ourselves to just a scatter, like I was saying, we can go beyond, okay? We can go beyond and then try and fit a straight line to the set of what? Of data, or we can even do this. Sorry. We can have a regression line to this data. Okay, my screen is not too huge. Yeah, so I'm trying to fit a line to that. Okay, where is this option for the line plots? Yes. Okay. Okay, we'll get that one later. The most important is we have the scatter plots for now. Okay, but I know there are options to put the regression equation to this. I think it's escaped me a little bit in the Excel, but there are many softwares we can use for the same purpose. Okay, so let's go back to our slide. Well, good. So we've looked at the concept of the scatter plots, what is used for, okay? Now, the next thing we need to understand is the scatter plot does not help us to, even though it can tell us the direction of relationship, whether it is positive or negative, or it's a strong positive relationship, or I mean, uh, a mild relationship in the sense of the dispersion from what? The central point, or dispersion from the central line. Okay, it does not help us to quantify the amount of relationship between what? Your X, your predictor variable, and the dependent variable. So a very important measure of relationship is what we refer to as a Pearson's moment of correlation. Okay, and your R is a correlation coefficient. Now, in very simple terms, okay, the formula for R is indicated as shown. So please write it down. Write it down. Okay, and I'll supply you with another slide, which leads us to this formula. Yeah, this is a computational word formula, but for the sake of time, I just want it to be very brief. Okay, so this is a computational formula which we're going to use. So take note of it. We'll solve an example, okay, based on this formula. Okay, so what this formula is telling us is, if you are giving data in terms of your X and your Y, okay, which is the predictor and the dependent, you first have to find what? You see, the formula says XY, summation XY. So find X times Y, okay? Then the next one is, this one says sum X, so this will just be the summation. You sum everything here, eh? So that one you only have to sum, sorry, this summation X. Then summation Y, you sum the Y data given. Then this one says summation X squared. So first you have to find X squared, okay, and then you sum it. You understand? Good. Then the next one says summation X all squared. This is the summation X. So this one, you don't find it again. Then the next one is summation Y squared. So find Y squared, okay, and then you sum it. So anytime you are giving your data, which is X and Y, you have three columns. One column for X times Y, the next column for X squared, and then the final column for what? Y squared. Okay. And then once you are done, you sum everything and then come and put into the formula. Okay, good. Now, let's spare the theories. I just want us to go straight to the example so that we can do some interpretation. Okay, now in our first example here, we have data. Okay, we have this data set here. Okay, for this data, I think, let me see if I can get the more detailed presentation. Very good. So let me use a more detailed example, okay, from the slide I said I'll send to you. Okay. So in this example, okay. Yeah, so I have the data here. I hope you can all hear me. Now, this this data here is for, it says the following data are diastolic blood pressure measurement taken at different times after an intervention for 5 persons. Okay. For each person, the data include the time of measurements and the diastolic blood pressure. Of interest is the relationship between these two variables. Now, here, time will tell your pressure. You understand? So your X is the time, and then your Y is what? The pressure. Okay, so this is the data given. X and then Y. So like I explained, anytime you are giving the data, you should have additional 3 columns. This is just a patient number, patient 1, 2, 3, 4, 5. So this one doesn't count in the calculation. Okay, good. So you first create your X squared, Y squared, and then XY. You always have to have these 3 columns. Okay, good. So when you are done, X, this is the X, this data will be given. X and Y will always be given. Okay, so you create the additional 3. So you square this, 0 squared, 5 squared, 10 squared, 15 squared will give you 225, and then 20 squared will give you 400. Then you do same for Y, and then you multiply your X and Y. So 0 times 72 will give you 0. 5 times 66 will give you 330. 10 times 70 will give you 700. Okay. Then after you are done, you find the sums. So 0 plus 5 is 5, plus 10 is 15, plus 15 is 30, plus 20 is 50. Then 0 plus 25, 25 plus 100, 125, plus 225 will be what? 450 plus 400, 350 plus 400 will be 750. Then sum your Y, sum your S squared, and sum your XY. So once you are done, the formula says what? The formula says that what? Your R okay, your R value, the coefficient of correlation is what? N is what? How many observations do we have? Your N is what? 5. Okay. Then the next one is what? Summation XY. So this is summation XY here. I don't think I have much space on this page. Let me minimize it a bit. So like I was saying, the formula is R is what? Is N summation what? X, Y minus what? Summation X times summation what? Y over, okay, the square root of what? N summation X squared, okay, minus what? Summation X all squared. Okay, then same for the Y side, times square root of what? N summation what? Y squared. I'm sure you captured that earlier. Okay, minus what? Summation Y minus summation Y what? Squared. Okay, good. So just substitute the values in. So this will give us, this should give us what? R will be what? 5 times summation x, y. Let me see if the solution is down. We just make use of that. So, oh, this is a different approach. So let me just stick to what I'm doing. So this is 5 times summation x, y is what? Is 3310. Okay, then minus summation x. Summation x is 5. Okay, times what? So that will be 5 times summation y. Oh, I think summation x is 50, sorry. So 50, this is it. This is the summations. Okay, so that is 50. Summation y is what? Times 338. Okay, over, then you substitute your other values in there. 5, n is 5. Summation x squared is what? 750. Okay, good. Minus summation x. Summation x is still 50, but this time you square it. Okay, so that will be 50 squared. Okay, then we have times, the other side will be the square root of n summation y squared. Y squared is a huge value. That's 22,000. So that's 22892. Okay, minus what? For the lack of space, I'm writing there. So minus your y squared, which is 338 squared. 338 all what? All squared. Okay. Yeah, then you have to do the calculation. So when doing the calculation, you do this calculation here first, and then find the square root. Then you do the one under the other square root, you find the square root of it and multiply. Okay. Then after that, you come and do for the numerator and then divide by the value you had down there. Okay. So you continue that example for me. Okay, at home. Now, having said that, let me quickly move on to the next step. There is a way to test this relationship, okay, which we have just looked at. There is a way to test the relationship. Now, why do we have to test the relationship? Sometimes we could have, you calculate the value of R, okay, and you get what we call as a spiral correlation. Okay, yeah, so we need to test whether this R value, the relationship, we are all, in very basic term, what we are saying is, because your R is being calculated from a sample data, okay, and you want to make inferences more or less on the population, you have to what? Conduct a hypothesis test. Let me put it that way. Okay, yeah, just to test the significance of your correlation coefficient. Okay, now to do that, I'll go back to the previous slide. Yeah, so to do that, you need to first test. Okay, we'll look at the interpretation of the R value, but in the test of the correlation coefficient, you go through these steps, and it's just like normal hypothesis testing. So you first make a claim that the correlation coefficient is 0, meaning it is not relevant. If it's 0, relationship is 0, then it means it's not what? Relevant, or it is not significant. Then next one is the opposite statement will be it is not 0, or it is different from 0. okay, which means it's significant, okay. Good. Then the next step will be to select your significant level, like any hypothesis testing. The third step is to select your test statistic. Now here, the test statistic is going to be T is equals to the R value you calculated times your sample size minus what? 2 over square root of what? 1 minus what? The R you calculated squared. Okay, good. And then here is just the normal hypothesis testing process, okay? But your degrees of freedom in this case is going to be given by, you're going to read T alpha on 2, then N minus what? 2 degrees of what? Freedom, okay? Because we are dealing with what? A two-tailed test, okay? Good. So, for example, if we calculated our R, let's say the R was maybe 0.8, okay? And in that example, your sample size was 5. Then the T test statistic will be 0.8, okay, square root of what? 5 minus 2 over square root of 1 minus what? 0.8 square. Okay, good. Then once we find the calculated value, the next thing is you go to the critical value. And like you read the T table, you go and find the critical value there. Okay, yeah, so we'll go and read T of 0.025. And then since your N was 5, 5 minus 2 is what? 3. So you go and read T with 0.025 and okay. Yeah, I think the network just went off. So like I was saying, you go and read the T. We'll look at an example if we meet in class, okay? So that will be T of what? 0.8. No, I was on the reading of the table. So you go to find your critical value, okay, which will be T. So you go to the T table and 0.025. And then you read the degrees of freedom, which will be what? 3. Once you obtain it, you compare the calculated value here, the T statistic value, with the critical value, because the rejection will be on the right and on the left. So you compare whether the calculated value will lie in acceptance region or rejection region, okay? If it lies in the acceptance region, then we don't have evidence to reject the claim. If it lies in the rejection, then we have enough evidence to what? To reject the claim. Okay, any question? Any question, class? If you have a question, just raise your hand. I will mute you. If you have a question, raise up your hand for me to unmute you. Okay, so let me touch on the very last thing for today, since nobody is raising the hand up. I'm going to touch on the very last thing for today, and we'll meet tomorrow as well. We'll start with matrices, okay?